Okay, so the properties that are written on the screen right now, you may remember a little bit about other properties that look similar to them from advanced functions. So when you did the MHF course, we worked with logarithms, and there were properties of logs, and we had proven them in that course. So we're not going to prove these ones because the same properties apply. So if you're not sure, let me know. I can point you to a reference for that. But the first one is the natural log of e to the x is equal to x. Um, we could go through maybe in some kind of principle and kind of show you that, but just recall that when you're writing the ln or ln, the natural log, that the base is e, okay? And same thing over here, the base here is e. If we want to show a little bit of proof for that, what we could do is convert it to exponential form, and then you would see how the left hand and the right hand sides are equal to each other. Okay, but I think we'll kind of forego that. But that's something you need in order to make sense of stuff, then let me know and we'll put that in. So let's try out an example where we're applying some of this stuff. And let's try this one. Let's go with I want us to simplify the following. So that's ln, or the natural log, of the following. E to the 2x. Okay. So e to the 2x. Okay, so again, I'm just going to write that base e in there just for a little while, just so until we're cognizant that that is the base. It's not base 10, it's not anything else. So in order to simplify this particular expression, I think we need to call upon one of the properties. So based on the properties above, any ideas on what we could potentially write down? I thought I heard somebody whisper in the back something with the 2. No? What do you think? You see it as being 2x? Okay. Okay, given the fact that, why am I saying that? Well, I'm referencing the property above, that the natural log of e to the x is x. Okay. So you can sort of hopefully appreciate the likeness of the parts that are there. And that's really all I'm going on is, that's a really poor color. That's a terrible color. Let's back that up a little bit. Let's go with something more, maybe the blue will be good. Oh, that's better. Right? So you can kind of see, right? You can see the parts. They all seem to align. So we're using the property to simplify the expression. Okay. Does that seem okay? So maybe we'll try to focus on one that uses the second one. So let's try another one. Let's go with part B. And let's pull another one in here. Let's try. Oh, this one looks good. This one looks really good. So e to the ln 3x, and that gets multiplied by the natural log of e to the 2x. So if you take a moment and just reflect back on the properties that have been provided, suggestions on the first one. Yeah, Sarah's? Okay. Any seconds on a 3x? Oh, look at the support. People just jumping out of their seats to support you on that. Definitely 3x. Next one. Yeah, 2x sounds good. Yeah. So in the end, 6x squared. Okay, so these expressions involving logarithms or natural logs ended up producing an answer that was polynomial in nature. So what we should do is maybe reference the properties that have been used. So for this first portion, what we're going to see is this property here, e to the ln of x is equal to, right, would be this one up here, I guess, followed by this portion here. I'm just going to scroll back up, make sure I've got these down okay. So ln e to the x. So those are the properties in use. Any questions at all about the choices that you heard your peers take with that? Okay. So we're not going to get into a lot of application. I want that part to be for you guys. This is kind of some base knowledge. I want you guys to take the base knowledge and put it into some context. So you'll see questions involving, what do we have here, voltage again, so that comes back to haunt us in a very nice way. Some questions involving populations, so bacteria, that kind of stuff, maybe some finance, so we'll get to that in a few moments. Video time, what are we running here? We want to try to keep it on the short end, 6 minutes, that's good. We'll go for maybe another 6 and then we'll cap it there. So let's try something else. Let's go with, why don't we try solving some equations with logarithms? Let's try to solve for x in these cases. And we'll put that in there just so we know how much to round to. Alleviates the question, what do I round it to? So let's run through 2 or 3 of them. Let's try this one. So we have e to the 2x. Okay. So again, e is just, it's a base, it's a number. It's about 2.7, so it's like any other number. Okay. Except it's just a little more special. So beforehand, you guys were solving exponential equations and you had tools for doing that. Right? So I just need you to call upon those tools. Any suggestions on how you might try to unlock that x, or how to get that x into a position where we have a solution? Catherine? Okay, so go natural log of both sides. Sounds like a good move. So you're saying I would write natural log of both sides. So we have that. Now there's 2 ways we can move. Okay, there's 2 different directions. I think we should probably take those 2 directions so we have, different possible strategies in solving. Devin, you want to suggest? Okay. So 2x goes here. Now, if you don't mind, what I'm going to do is I would like to just take a moment to record the properties that are being used. So this one here, just so it's good for the video that's being casted. So this was take the natural log of both sides. And I think I'm going to try to keep the color coding the same. I don't want to use red here. I'll keep that black. And then you said, Devin, in blue, it's 2x, and that's because of the property that ln e to the x is simply x. Okay. Well, moving forward from here, I think we've got it. Solve for x. So we're going to take half of the natural log of 12 and to 3 decimal places. We're going to have ourselves an answer. And that answer is 1.242. Any seconds on 1.242? Okay, that's a lot of head shakes, yes. Awesome. So, as mentioned, there might be one other way to move with this one, and I think it's an important feature. So what we're going to do is we're going to start with this line up here. So I'm just going to group this bit of text together, and I'm going to clone that and bring it forward. Clone, clone, clone. Okay, let's call this method 2, if you will. So method 2 has to deal with a little known fact that we had proved last term when working with logarithms, where we took the log of a power. So this really is ln e to the 2x. This is the logarithm of a power. There was a power rule. Did I recall that one? What is it that we would do with this here to use the power rule? Going off your knowledge and understanding of that rule. Yeah. Yeah. According to that rule, it became the coefficient. So we have 2x by the natural log of e, which is equal to ln 12. Okay. Well, when you take the natural log of e to its own base, any suggestions on what you think that's equal to? It's equal, exactly. It's equal to 1. It's kind of similar to, remember how the log of 10 to the base 10, that was equal to 1? It's very similar, except that's base 10 log. Here we have base e log. So it's the same thing. So that's going to give us a 1. And now we're back to the same position, right? Solve for x. So the moral of the story there is that the ln, or natural log, of e is 1. Any questions about the tactics that were employed in solving that one? Okay. Well, why don't we round the video out? We'll do one more. And if you have any questions, just bring them forward. So let's try. Let's try something that might have some logarithms in it. So instead of having exponential form, we'll have a logarithmic form. Let's try this one. Oh, sorry, I wanted to go logarithmic, didn't I? Yeah, this looks better. Let's try this one. Okay. So again, this one, there's 2 ways that we can move forward on it. Now, I think, Devin, last time you suggested you used a property, I think, to begin the last one. So we could do the same thing here. This expression here, right, this base e logarithm, that boils down to, nice, a little bit louder there, Lisa? Yeah, x squared. Okay, and in this case, we can solve for x. Okay, so the root of that equation, plus or minus 4. Okay. Alternatively, what do you think the other method is? It's rooted in the definition of a logarithmic function. It has a connection or relationship to a little known something called the inverse. Well, what if we converted it to exponential form? Right? Because they happen to be inverse functions, so we could use that property to solve the equation. So what we would have is, because it's a base e log, we would take e and we would express that to this value here, which is going to be the exponent, and then we're going to set that equal to the value of that power. And then because the bases are the same, we can then say that the exponents are identical. And then plus or minus 4 is your value for x. So there's just a few examples that give you an idea of how to employ the properties in solving logarithmic and exponential equations that involve base e. Okay. Any questions before we move forward on a few practice problems? Okay.